Welcome students. We got a beautiful question. I thought I can bring this to your attention. So we got a circle, a semicircle. So let me draw the circle. Okay, we got that. And now I need to place the circle inside a square. So let me do that. So first, let me make sure that there is a tangent there. Okay, now there is a hit. Okay, fair enough. So we got a beautiful figure. This is the center. Now we are expected to find the area of this region. Now we've been given, let me take this as A, B, C, D. We've been given E to be as 6 units, and let me take F this to be as 3 units, right? So these are the informations that have been given, nothing else much. Now having got this information, what I'm going to do is I have to first, step number 1, I need to find the radius of the semicircle. That's important, we need to get that. Let me take this point as O. OE is equal to OF is equal to R units. So this side and this side are equal. Now from O I can actually hit the circle, right? I can make that hit. Now what I wish to do is I would like to drop there is a tangent here, so I wish to make use of it and try to hit it. Now apparently the figure is not to be scaled. Okay, so I will make that connection. Now before I could do that, what I would like to do is I would like to drop a perpendicular from F to AB. So step 2 is drop a perpendicular from F to AB such that the line meets AB at G, right? So exactly from here I am dropping a perpendicular, right? So this point is G. So this means FC is equal to GB is equal to 3 units. So this strip is 3 units. Okay, fair enough. Now I would like to drop a perpendicular. Step number 3, drop a perpendicular from O to AB such that the line meets AB at GH, okay, at H. So I'm dropping a perpendicular. Now this is hitting here, right? This is hitting this. There is a touch here, there is a hit here, and this is actually the radius, the capital R, I should say lowercase r, this entire length. So let me take H. So OH is equal to OE is equal to OF is equal to R. That's critical. Now step number 4, draw a perpendicular from E to OH. Right, I'm drawing a perpendicular from E to OH and let it meet at I. Let the line meet OH at I. So this is a perpendicular, so this is going to be 90 degrees. Now what I wish to do is, initially I was thinking of stretching the line, but there is no point, there's no point in making the stretch. It's okay that I restrict myself to this line FG. Now step number 5 is draw a perpendicular from O to FG such that the line meets FG at J. So this is a perpendicular, so I'm hitting here. So this is going to be 90 degrees. Fair enough. Okay. Now EI is actually parallel to OE, and the most important part here is the angle made at E will be the same angle made at O, right? Both of them are perpendiculars drawn from the diameter. That is the important part. They're drawn from EF. So this angle is same as this angle. We already have 90 degree here. We already have a 90 degree here. So what can we say about the triangles? Consider triangle EIO and O. Let me draw from O to FG, the line meets at J. Okay. And triangle OJF by side angle, or you can say angle side angle. By angle side angle property, what do you see? Triangle EIO is congruent to triangle OJF. That's all. The solution is got. So since the triangles are congruent, so the sides would be equal. Now let us obtain the sides now, right? Now this, if I were to stretch this point, this is going to be hitting the circle. This is going to be hitting the circle, and the line is actually bracing the circle. Okay, the line is actually eating the circle because of the lack of apparatus. The figure is little bit, what should I say? So we need to go by an approximation. So if I were to take this entire length as to be r, if this entire length is r, and this length is 3 units, so this is going to be, from r you take away 3, right? So that would give me the entire length, right? So taking that to be as r minus 3, this will be r minus 3. Now this entire length is r, this length is 6. So from r, I want this, I take away 6 units. So this is going to be r minus 6. So this, since by concurrency I can write this as r minus 6, right? So that's it. Now when I say angle side angle, it is also imperative that I jumped to this angle, but even if I don't mention this angle that is being made here is also one and the same, right? So these two angles will also be same. So in either of the cases, still we will be able to use angle side angle property. Okay, so having mentioned that, let me move on. So I'm going to consider triangle. Let us consider triangle OJF. Now by Pythagoras theorem, what can we say by Pythagoras theorem? R negative 3 the whole square positive R negative 6 the whole square is equal to, this entire thing is going to be the radius R. This is going to be R, this is going to be R. So this is equal to R squared, right? Excuse me. So if I want to expand this, this is going to be R squared negative 6R positive 9 positive R squared 12R positive 36 is equal to R squared. Now I can cancel one R squared off. 9 added with 36 is going to be 45. This is going to be 18R plus 45 is equal to, or I should say, we are getting a quadratic equation. Okay, since this is a quadratic, we have to try to solve it. So let me solve by minus b plus or minus. So this is 18 plus or minus root of 18 squared negative 4 5s are 20 2 16 17 18. So we are getting 18 squared. So let me find out what is 18 squared. 64 6, I have a 14 and a 8 and a 1 8 12 3 2 4. So 3 2 4 minus 4 5s are 22 16 180. So this is 4 4 from 2 I take 144. So this is equal to 18 plus or minus root of 144 divided by 2 is 18 positive 12 divided by 2, or okay, let me just calculate this. This is 30 divided by 2 which is equal to 15, or you have R is equal to 18 minus 12 divided by 2, 6 divided by 2 which is equal to 3. Now this is not possible. This is possible, right? Because of the sizes which we have here. If you were to take r is equal to 3, you get a negative value. So we can't. So r is equal to 15. So having got that, I can clearly place the value r is equal to 15. Now the most important part here is we are expected to find the area of the sector. So OEH. So first we have to find the area of the sector. Let me get the area of the sector. From the area of the sector, I will subtract the area of the triangle. So I will get this region, and then I will have to calculate the area of the rectangle. So this is going to be 6 units, 6 units, and from 15 you take away 3, you get 12. This is going to be 12. Right, so process is simple. So first let's find the area of the sector. Now to find the area of the sector, I need to get this angle, right? Now you can get this angle by many ways. So let me just find this angle. Let me take this angle to be as some alpha. Okay, so if I were to take sine alpha is opposite side 15 minus 6, that's going to be 9, opposite side divided by hypotenuse, so that's going to be 15 there. So 3 divides here 3 times, 3 divides here 5 times. So alpha is sine inverse of 3 over 5. So we need to get the value of alpha there. So let me just take my calculator. So this is going to be equal to sine inverse of 0.6. You calculate this, and this is the value you are getting, 36.86. Now I would approximate it to 37, right? Of course you are at your liberty to take it as it is, but I just want to approximate and get the answer. So I would be approximating it to 37 degrees. Now this is 90, so let me go back 90 and show it to you. 90 degrees plus 37, so we're getting 127. So what I would do, from 180 I will subtract 127, and that is giving me 53 degrees. So the sector angle is 53 degrees. So we have got it. Now having got the sector angle, let me find the area of the sector. So area of the sector, what sector are we talking about? OEH is equal to theta divided by 360 times pi r squared. So 53 degrees divided by 360, pi times r squared is 15 into 15. So let me use my calculator. 360. Okay, I can use 15 to divide this by 24 times, and I will multiply 53 into 15. Let me do that here. 53 into 15, that's going to be 795 divided by 24. Again it will have an approximate value, so let us see that. So this was multiplied with pi 3.14, so I'm getting this value 2496. This is divided by 24, this is giving me 104.01. so what I would do is I would take it as 104.01. that's what I can take it as. So we got the area of the sector. Now from the area of the sector, I will take away the area of the triangle. So we will have to calculate the area of the triangle. So let me use this page here. So area of triangle, what is that? OIE. OIE is equal to half times base times height. Half times, what is the base here? The base is r is equal to 15 minus 3, that's going to be 12 units, times the height 15 negative 6, that's going to be 9 units there. So 2 divides here, 6 times 6 nines are 54 square units. That is the area of the triangle. So from the sector I will take away this so that I will get this portion. So I'm going to get this portion. So let me find out this. So from 104.01 I subtract 54. This would be the remaining portion of the sector. So let me do that. 104.54, it's going to be 0 and 5, which is 50.01. So that has been got. So we have got that. We have got this portion. So this portion is 50.01. Now what is the area? So required region is equal to area of the rectangle. From area of the rectangle I have to subtract the remaining portion of sector. So this has to be subtracted. From the area of the rectangle I subtract this portion, I will get this portion. Okay, so what is the area of the rectangle? Area of rectangle is equal to base into height. Base times height. What is the base? The base is 15 negative 3, that's 12 units. The base is 12 units times the height is 672. So required region is equal to 72 minus 50.01. So let me subtract 72 minus 50.01. This is 9. I get a 1 here, and from 7 you take away 5, you get 21. So this is approximately 21.99 square units. This is the required region, right? So this is a beautiful question. You got the figure. Now what you can do is you can actually go a step further to find out if the answer that we got is acceptable. Now this is 15 minus 3, so this region is also going to be 12. This region is going to be 3. So 12 added with 12, 24 plus 3 is 27. So you got a length of 27, right? And 27 times 27, side into side, right? 27 times 27 is 729, and this region area is 21.99 square units. So that is sensible. So students, we had a beautiful question. We worked out really well, and give your likes and press the notification and subscribe to our channel. Until we meet again, thank you everybody.